Uh, all right, I'm going to talk about, my name is Odin Sanson, and I'm going to talk about simulating transients in the waterways of hydropower machinery. So my presentation will contain of first a little presentation of the background theory and how the transients are affecting the hydropower machinery, what has been done previously related to this project, what I'm currently working on, and what are the long-term goals of what I am currently working on. So, pressure pulsations or transients are pressure waves propagating in the waterway with the speed of sound. They will have an amplitude and a given frequency. And if the frequency of these pressure waves will hit the fundamental frequency of any of the structures in the hydropower system, it may cause resonance, which could have serious consequences for the system. During the lifetime of the hydropower system, it is going to experience a high number of cyclic loads from the pressure waves or pressure pulsations. And this could cause fatigue loads in structures in the hydropower system, which could lead to, for example, cracks on turbines affecting the hydropower efficiency or eventually causing failure of the hydropower station. So rotor-stator interaction and draft tube surges are two ways that these pressure pulses are generated. I will not go into detail, but the rotor-stator interaction is when the pressure pulses are generated between the interaction of the runner blades and the guide vanes. And the draft tube surges are pressure pulses that are generated in the draft tube where the flow is exiting the hydropower turbine. So the previous work, this project is related to a hydropower station called Kvildal near Stavanger, which consists of 4 turbines. And these turbines are connected in the waterway, which means that transients that are originating from one turbine may propagate through the waterways and reach the other turbines. So that makes this hydropower station an interesting research object. 2 of the turbines in the hydropower station have experienced more problems than the others, and the theory for this is that it's because of pressure waves or transients. The spring this year, it was performed measurements in the hydropower station, and in the measurements they were able to see frequencies related to the draft tube surges upstream of the turbines. However, why the turbines, some of the turbines are experiencing more problems than others were not yet determined. What I am working on is applying CFD and numerical analysis in order to simulate this hydropower plant. I'm comparing one-dimensional and methods with 2-dimensional and 3-dimensional CFD. So the one-dimensional method I've been looking at is the method of characteristics. It's a one-dimensional method that solves the wave equation using finite differences, and it's in 1 dimension, and it is computationally very fast and efficient compared to 3D CFD, which is computationally heavy, and doing when considering modeling a hydropower station with all of the waterways and the turbines, doing a full 3D model of everything is unfeasible, and then you need to probably couple 1-dimensional and 3-dimensional model in order to create a proper full-scale model to see how the pressure waves travel in the waterways and interact with the other turbines. But the 3D models are still necessary in regions where you have 3-dimensional effects. So what I have currently been doing is simulating a water hammer. And this is a pressure wave phenomenon where water is flowing through a pipe, and then it's closed at the downstream outlet. And this creates a strong pressure pulse that is reflecting between the wall and the reservoir, and the pressure pulse is moving with the speed of sound, and the pressure pulse is generated because of the compressibility of the water. So I set up simulation using ANSYS CFX and compared it to the method of characteristics. And this is the method of characteristics with in the graph here. What the graph shows is the pressure just upstream of the closed valve. And the two methods that have been used here to model this is the computational fluid dynamics in ANSYS CFX and the method of characteristics. And as the idea here is to couple the models, you can see that coupling models that are similar but not exactly the same could possibly cause some dubious results when they are communicating or transferring between at the boundary where they are communicating with each other. If they are giving each other slightly wrong information, it could cause, for example, false transients to spawn in the simulation and give you not good results. The long-term goal of the project, ideally, is doing a full simulation of the Kvildal hydropower station using the theories behind one-dimensional and three-dimensional coupled modeling, and then use this to study how the transients interact with the turbines and how this is possibly affecting the system.
Thank you.